Why AI sounds so smart? AI sounds intelligent, and that's the problem. Because the moment it sounds intelligent, your brain assumes there's understanding behind it. You read a clear explanation. You see a structured argument. You watch it respond confidently. And it feels like you're interacting with something that understands, but you're not. You're watching prediction at scale. In the previous video in this series, we looked at what happens when prediction fails, what people call hallucination. Confident output detached from reality. Now we're looking at the more dangerous side. What happens when prediction succeeds? When it succeeds so well that it becomes indistinguishable from intelligence. Because when prediction works at scale, it doesn't look mechanical. It looks like a mind. Part 1. Fluency is a cognitive shortcut. Humans are wired to equate fluency with intelligence. When language flows smoothly, we assume there is structure behind it. When ideas connect cleanly, we assume there is reasoning behind them. When transitions feel natural, we assume someone is thinking carefully. In human interaction, that shortcut usually works. Fluent speech often reflects organized thought. So your brain built a rule. Smooth language equals smart mind. That rule is efficient. It saves cognitive effort. But with AI, that shortcut breaks. When a language model produces fluent text, it isn't demonstrating comprehension. It's demonstrating probability alignment. Fluency is what high-probability language looks like. If word A strongly predicts word B, and word B strongly predicts word C, the sentence feels natural. Natural does not mean understood. It means statistically expected. Expected language feels deliberate. Deliberate feels intelligent. But that's interpretation layered on top of mathematics. Underneath, the system is selecting the most likely next token given everything that came before. No awareness, no intention, just probability resolution. Fluency is not evidence of thought. It is evidence of strong pattern prediction. Part 2. Coherence is constraint accumulation. Now we go deeper. A model generates text one token at a time, not full paragraphs, not complete ideas. Tokens. Each token is selected from a probability distribution. That distribution is conditioned on the entire prior context. Every word matters. Every sentence narrows the future. If the model begins with natural selection, operates by, the probability space collapses. Biological terminology rises. Evolutionary framing becomes dominant. Certain verbs become more likely. Certain metaphors become less likely. The model reduces its own degrees of freedom. This is constraint accumulation. Each prediction limits future predictions. Each correct continuation deepens the statistical path. As the sequence grows, randomness decreases. Not to zero. But directionally, the model is not planning ahead. It is following probability gradients. Those gradients were shaped during training. When the model continues consistently, it's because the probability landscape is stable. Earlier tokens suppress unlikely branches. Likely branches reinforce themselves. This creates momentum. Momentum feels like direction. Direction feels like intention. but intention implies internal goals. What's happening here is recursive conditioning. The model becomes statistically committed to the path it has already taken. It must remain coherent with its own prior output. That internal consistency feels like reasoning, but it's constraint propagation, not understanding. And because instability gets suppressed, the output appears stable. Stability feels intelligent, but stability can emerge from mathematics alone. There's another layer here. The model doesn't just track surface words, it tracks relationships between words, grammatical roles, semantic proximity, topic continuity. So when it predicts the next token, it isn't randomly selecting vocabulary. It's resolving tension inside a probability landscape. Some continuations create instability. Others reinforce coherence. The system naturally moves toward reinforcement, not because it prefers clarity, but because reinforced paths are statistically stronger. That reinforcement compounds, and compounding reinforcement creates the experience of flow. Flow feels intentional, but it is emergent from constraint. If this kind of mechanism-level breakdown helps you see through the illusion, subscribe. This series builds layer by layer. In the next breakdown, we go inside a single token prediction and examine what actually happens there. Now, let's look at structure. Part 3. Structure is pattern density. This is where the illusion strengthens. Human experts write in structured formats: definition, mechanism, example, clarification, conclusion. Across millions of documents, this pattern repeats. Academic research, technical documentation, textbooks, policy papers. The model doesn't store these like a library. It compresses their statistical regularities into parameters. It learns that explanations follow certain arcs. It learns that arguments introduce premises before presenting conclusions. It learns that objections are often followed by rebuttals. These patterns become statistically dense. Dense patterns become dominant. Dominant patterns become reliable continuations. So, when you prompt the model with a question, it activates a high-probability structural template. It does not evaluate clarity. It does not choose organization. It predicts the structure most frequently associated with that prompt type. Producing structure does not require understanding structure. It requires exposure to structure at scale. Compression amplifies common formats. Outliers get diluted. Repetition strengthens probability weight. So the most common explanation patterns rise to the top of the distribution. When the output mirrors expert formatting, it feels like expertise. But mirroring is not mastery. It is high-fidelity pattern reproduction. The system is not reasoning through a framework. 'Tis reconstructing a statistically dominant one. Structure feels deliberate. Deliberate feels cognitive. But pattern density is not cognition. It is compression operating at scale. Aggregation can look purposeful, especially when the dataset is massive. But aggregation is not awareness. Part 4. Scale amplifies the illusion. Now we reach the multiplier. Scale. Early language models were small. They captured shallow correlations. They contradicted themselves quickly. They lost coherence across long responses. Their limitations were obvious. As parameter counts increased, capacity increased. More parameters mean more relational storage. More relational storage means finer distinctions. Subtle tonal differences, long-range dependencies, cross-paragraph consistency, context reactivation. Scale increases representational resolution. The probability landscape becomes more detailed, more stable, more coordinated. The model can maintain thematic alignment across longer spans of text. That stability feels like planning, but planning requires internal goal states. There are no goal states during inference. There is no reflective pause. There is no internal evaluation of truth. Training shapes the probability landscape. Inference traverses it. Training carved the terrain. Inference walks across it. Nothing new is being understood in that moment. The system is resolving probabilities inside a space defined long before your prompt arrived. At sufficient scale, prediction becomes so stable that it resembles intention. It resembles foresight. It resembles reasoning. But resemblance is not equivalence. When alignment with reality holds, we call it intelligent. When alignment breaks, we call it hallucination. Same mechanism, different outcome. You are not interacting with a mind. You are observing a statistical system resolving the next most likely token. Again and again and again. The more stable the resolution, the stronger the illusion becomes. AI sounds intelligent because prediction works extremely well. Fluency from strong token alignment. Coherence from constraint accumulation. Structure from compressed pattern density. Stability from scale. When those layers align with reality, the output feels like thought. But beneath the surface, nothing is thinking, nothing is aware, nothing understands. There are no beliefs inside the model, no internal narrative, no subjective experience. There is only next token prediction executed across a massive parameter space. If this dismantled the illusion clearly, subscribe. Next, we zoom into one prediction and watch how the system chooses the next word. AI doesn't think. It predicts